Section 6.2, adding and subtracting denominators that are different. Recall when adding fractions with different denominators or subtracting, we first need to find a common denominator. Our work is easier when we use the least common multiple of the denominators. And here we have an example. These denominators are not the same. We'll do a prime factorization on the first denominator. 9 breaks down into a 3 times 3. The second denominator is virtually factored out, or prime, 3x. Our least common multiple, which we're going to create for our common denominator, has to have common factors to the highest power of any one of the denominators. We need a 3 to the second power, and since the second denominator has an x, our least common multiple will have to have an x. When we simplify, our least common multiple is 9x. We're now going to rewrite each of those original rational expressions as needed in equivalent form that has that least common denominator, or the multiple that we found. So our first fraction has a 9, but it needs an x. So we will multiply the denominator by x, but also the numerator by x, because of the fact that x over x is 1, and we're not changing anything value-wise, but we're transforming it into an equivalent rational expression. Similarly, the second fraction, 6 over 3x, needs a multiple of 3 to bring it up to that least common denominator of 9x, and so the numerator will need to be multiplied by 3 as well. Simplifying, we have a 4x over 9x, a 18 over 9x. We now have common denominators. We can combine the numerators over that common denominator, and we're done with the exception of always simplifying your rational expression. To know whether this is reduced, we'll factor first. In the numerator, greatest common factor is 2, leaving a 2x minus 9 over the common denominator of 9x, nothing to be done there. And looking numerator and denominator, there is no binomial. 2 and 9 don't have anything common, but it's clear now, because it's in a factored form, that it is simplified as far as it can go. This next example is a subtraction of two rational numbers with unlike denominators, but they're so close. If this 16 was only a negative 16, and if this x squared was only a positive x squared, they'd be exactly alike. Well, if you remember from factoring, we had a technique that changed the signs, and that changing of the signs was factoring out a negative 1. Factoring out a negative 1 changes the 16 into a negative 16. Factoring or dividing by a negative 1 changes the minus x squared into a plus x squared. We now have same terms, and just to verify that, do your distributive. We're back to what we had. Simplifying this, we have our original rational expression, nothing changed, but we have a positive divided by a negative is a negative. Subtracting a negative turns into a plus. Minus and minus is plus. 4 in the numerator. And while we're at it, let's rearrange. Let's put our x squared first and the minus 16 second. So again, this subtraction with this negative canceled out, giving us a positive. We now have common denominators. We can combine the numerators. And always on guard for simplifying or reducing the fraction. The numerator, there's nothing to be done. But in the denominator, we have a difference of squares, which factors into an x minus 4 times an x plus 4. And now looking in the numerator and the denominator, we do have a common binomial factor of x plus 4. When you have the same thing over the same thing as a factor, it cancels out, leaving a 1. Our final answer then is 1 over x minus 4. In this next example, we have a rational expression minus another rational expression where this second fraction has a denominator understood to be 1. So our least common multiple of the denominators is simply 5x minus 2. The first fraction needs, or rational expression needs, nothing done to it. The second, however, needs a factor of 5x minus 2 so that we can get the common denominator. And if the denominator gets multiplied by that quantity, so does the numerator. So essentially you're multiplying by a 1. We can then do a simplification. This subtraction can be thought of as plus a negative and distribute. So we will end up with a negative 4 times 5 is a negative 20x. A negative 4 times negative 2 is a positive 8 over the common denominator. We have our common denominators, so we will combine the numerators, 3x plus the negative 20x plus 8, all over the common denominator of 5x minus 2. Simplifying, we have a negative 17 when we combine our 3x and minus 20 plus the 8 over 5x minus 2. Factoring wise, to see if we can simplify, 17 and 8 have nothing common, neither do the 5 and the 2. So this is our simplified rational expression for that operation. In this next example, we're adding and subtracting rational expressions. We're looking for our least common multiple. Well, the first fraction, it's clear, it's an x minus 4. The second fraction's denominator is an x plus 3. And if we factor x squared minus x minus 12, it factors into an x minus, whoops, need to write my x there, x minus 4 times x plus 3. Our least common multiple, it has to have these two factors, which, good news, is, whoops, I'm having difficulties there apparently, are, that should be a 4, are the factors of these two rational expressions with only the binomial. So, before we add, we need to change each one of these, and subtract, we need to change each one of these rational expressions so that they have that least common multiple. So our first fraction has the x minus 4, but it needs the x plus 3. So we will multiply the numerator by x plus 3 and the denominator by x plus 3. The second fraction needs the x minus 4 because it already has the x plus 3. So we will multiply the numerator by x minus 4 and the denominator by x minus 4. And the second, or the third fraction here, nothing needs to be done other than maybe replace, so we can see the factors of that denominator are in fact x minus 4 times x plus 3. Each one of the first two fractions was multiplied by a very special one that brings us up to a common denominator, and simplifying that, we have an x plus 3 times 1 is x plus 3 over x plus 3 times x minus 4, minus, we have a distributive property here, x times x is x squared, x times minus 4 is minus 4, over the common denominator of, and order isn't important. If you want to see that they're all uniform, we could put our x plus 3 first, followed by our x minus 4, plus we did nothing with our last rational expression other than we factored our denominator. And I'm going to switch those two around just so it really looks like a common denominator between all three rational expressions. Because we now have our common denominator, we can combine our numerators. And being careful, when we do this, it's not only subtract the first term, it's actually subtract this whole numerator. Because they're all common denominators, we'll do the indicated operation. We're going to take x plus 3 minus the quantity x squared minus 4 plus the quantity x squared plus 6 all over the common denominator of x plus 3 times x minus 4. Subtraction of a quantity, we can change the signs and add, and simplifying this further, we will end up with x plus 3, subtract x squared, minus a minus is plus 4, plus our x squared plus our 6 all over, again, that common denominator. Combining like terms, our x squareds actually cancel one another out. We have an x plus 3, 4 add up to be 7, plus 6 is 13, all over the common denominator of x plus 3 times x minus 4. Well, clearly this binomial is not common, so we have our answer simplified and in reduced form.